Alright, this is a Huff and Puff wrap-up video for those of you who think you might want to go down that path of building a Huff and Puff. Now, this unit here, this frequency digital readout, if you get the manual for it, which I told you how to find it in one of my previous videos, its resolution is 100 hertz. So this thing's going to bobble on you, make you nuts. Okay? Now, a Huff and Puff set up for the United States for like 80 meters is going to have a lock frequency of 70 hertz. So as you tune down the dial, it's going to lock in every 70 hertz. So it might not land exactly on, like, say you tune it to 3.5 megacycles. Well, put plus or minus 70 hertz and plus or minus a little bit. In other words, it might not lock exactly on 3.5. It's going to be 70 hertz off either direction, or it may be dead on 3.5, but then as you go down the dial, it locks every 70 hertz. Now, the other thing that happens with a Huff and Puff, it's only good for an overall, for each selection that you make of the chips, the pin number, the pin out of each chip. It's only good for 1 megacycle. Okay, so you set it for like 80 meters or 120, and then I want to tell you, you want to look for an all-band Huff and Puff oscillator. This guy went into great detail. He showed how he made an all-band Huff and Puff stabilizing oscillator. Okay, and he shows you his oscillator, the values, his testing method. He's got waveforms, and I did tell people this. Now, people don't bother to watch the video. Can I have the link? Can I have the schematic? I told you the link. Okay? You didn't watch the video. That's why I'm taking a break. I'm getting away from this. I'm tired of you people. I'm a builder. No, you're not a builder. Where's your videos? I'm calling you out, pal. I'm calling you out. Where's your videos? If you're going to say you're a builder like I am, where's your videos? Okay? Now, the other thing you might want to find is, I'll just see if I find it here. I know some people are. Hans Summers. This here one. Simple, fast, Huff and Puff VFO stabilizer. Okay? I showed you this page more than once. This is a very simple circuit just to see it latch. Okay? And this is at 9 megacycles. Okay? So, this Huff and Puff thing, right from the beginning, has had problems. Okay, it's not the greatest. Okay, but I chose it as an idea. I said, let me see this. And then when I saw this Holy Grail page, where the guy, and he doesn't have his name, he only has his call sign. And I showed you that on one of the videos that nobody seemed to watch. An all-band Huff and Puff oscillator. Okay. He goes through the whole thing, okay? I found that, what, 2 weeks into it, playing with that other circuit, that the guy says, well, that wasn't my best shot. He posted it, I built it, it doesn't really work right. But it was the idea that he wanted to get across. And I was looking for a circuit that worked. And I built it, and it didn't work, and that's because it's more of a theory than a practical circuit. And then I went looking, and I spend days. I tell you guys, I spend days. And I only ask a question to these guys when I get to a certain point, and then I need just a simple answer. Like in the case of this circuit, you know, looking at the values, I suspected it wasn't an American circuit, and sure enough, he set it up just to see it work. That's what he did it for. Now, this circuit here has been copied by so many people that want to put their name on things. Okay? And that messes up, and they say that the oscillator stays within 10 hertz, and a lot of this stuff is hype. Okay? There's a lot of that on the internet. So you actually have to build the thing and get it working to see the truth. Like this thing here. Like this module. It's 100 hertz. And also, when you put these guys into it, okay, I have some 60s and some 50s, and here's my HP over here. Okay, this HP has been calibrated by me with a frequency standard, and it's very accurate. And these things are very accurate, all right? But this does not read accurately, okay? It's not even close, okay? Yeah, it does so many hertz all the way up to 1 gigahertz, but it's junk, it's crap, okay? And you keep thinking, I'm going to build something, put this on, it's crap, okay? It's like that DDS module or that DDS radio. It's crap, okay? They sell these things at a certain price point. I got sucked in. I totally admit it. You know, I'm thinking over the years, you know, let's say this is 30 years old, okay? In 30 years, they should be able to make something this small, as accurate as it, but they don't. They dummy stuff down. Instead of using a bunch of divider chips and gates, they let a microprocessor do the work. And it's not that great of a deal. And that's what happened to this. But the project's officially over. I am cleaning up. Last night I didn't sleep that good. And the skunk made a visit. See, the skunk, we have skunks that come through at night. And when the warm weather starts, they spray. And it creeps into the house, whether you have the windows open or not. And then you lay there smelling skunk. And some nights, you swear the thing is in the house with you. That's how strong the smell gets. You know, I don't know if you guys live in an area. And the problem with the skunk is there's people in the neighborhood that put cat food out for the cats. So we have a big contingency of skunks because they have a food source. All right. And every so many years, the association puts out traps and traps some of the skunks. But when somebody's constantly feeding the skunks, you can't trap enough to get rid of them. And they don't starve to death because there's so much cat food out there. The cats come in and they get the cat food and whatever they leave behind, then the skunks come in and get. And it's one of the annoying things I have to put up with, okay, in my lifetime. And then I'm laying in bed, and I went to bed and I had the covers on me because it was cool, or I was cool. And then later on that night, you know, your temperature drops, and then I woke up red hot, and I'm laying there and I'm thinking about this circuit. It's a disappointment. It does work better than the Franklin oscillator alone. It does keep the Franklin from drifting, but there's so many things you got to do with it in order to get it to work. It's not a good thing. Okay. Now there was a Huff and Puff type circuit. A guy in the UK made one with a microprocessor, and he sold it for a while. But I don't know what frequencies it did. Even the ad for the thing wasn't that good. Okay. I always have questions that seem like they assume you know what the thing's for. They don't mention the range, the accuracy. It's just, we're selling this. Now we're not selling it anymore. It's funny stuff. But I'm taking a break, man. You know, like I said, people are saying I'm a builder. No, without videos. I'm pulling that. Fran Lab reposted her video where she goes after people for telling her what to do and the different things she puts up with. She or he. It's a transgender person. But anyway, yeah, I need break. I really need a break from this stuff, because this project was supposed to be a break, but every time I get stuff off the internet or products off of eBay, this disappointment sets in pretty quick. And that's because nobody puts specifications anymore. They let you assume it's going to work for you, okay? And they sell a boatload of these things. I know they do. There's like 30 vendors selling this thing. And I know 99% of these, they might see 9 volts. The person will put the 9 volts across it, see it come up, and then they'll put it away somewhere. And it'll never be used for a circuit. They'll never find out how much of a piece of crap it is. I understand that now. I spent years working with people and understanding how they lose interest so quick in things. And I stay with stuff. And that's an addiction. Okay? I admit it. I'm addicted to circuitry and to electronics and to digging deep and finding the answers. Other people aren't like that. They do enough of it to talk it up. Now, when I was growing up, my father used to read an article in the paper and then talk it up for years like he actually did it. And that's how I learned that. And then I would come back from a 100-mile bike ride, And he started asking me about the different areas I bicycle rode through. And I said, I'll be honest with you, Dad. There's arrows on the road, painted arrows that we followed. And you might see a sign for a town, but it doesn't mean anything. What you're looking for is the next arrow. You're riding as fast as you can ride, and maybe a place to stop and get water and to get food. And he goes, well, how did you? I'm not going to stop and look at the scenery. Well, you look at what you can see as you're bike riding, but you're not going to veer off 3 or 4 blocks to go see like the Air Force Base. I think it was McGuire's Air Force Base in South Jersey. You see it off in the distance, and you see the airplanes, the big airplanes, C-57s. Well, anyway, those giant aircraft that they practice on, and you see them taking off on you. And then one ride, we did go down past the Lakehurst hangar that they kept the dirigibles in. Yeah, you go past, once in a while, you do go past stuff like that. But my father was like on a different planet with stuff. He would talk about things that he read in the paper, and I'm like, go do it. You know, like the Nike, just do it. And that's what I realized about myself is I talk about things I'm doing, right? Other people talk about things they're going to do that they never going to do, okay? And you're telling them what you're doing, and then they cut you short and they start telling you this fantasy instead. And you're standing there, now you listen to someone telling you something they're going to do. They never do it. They're dead. They die before they do it. I can actually name names of people. I'm going to do this. I'm going to do that. I'm going to do. They're all dead. They never did any of it. Okay. Meanwhile, I've been slogging along with all these different things, and with this oscillator, I just wanted a really accurate oscillator with a digital readout, so I can make this little receiver. And my other receivers that I built, they're fine, but I thought it would be really cool. And then the first thing that showed up on this digital frequency module is it takes almost 3/4 of a second to sample and display the frequency. So if you're going up and down the dial pretty fast, it can't keep up. That was the first problem. Then you find out it drifts. Oh, yeah, I meant to tell you, besides it being 100 hertz off, it drifts. Like I showed you, it was bobbling. Well, if you watch the video, it goes from 7 to 8. No, wait, it was going down in frequency. It went from 8 to 7, or 9 to 8, and then later on it went to 7. So the oscillator that's on that board, it's supposed to be a pretty decent one. It's not. It's a piece of junk. Okay? Or the circuitry itself has some type of the gates in there, and the microprocessor changes with temperature. Okay? I don't know. I'm not going to go any deeper into this, because it's a piece of crap. There's no way to fix it. Okay? And then if you go on eBay and look for other frequency counters, there's pretty ones with different colored LEDs. Still the same circuit. Okay? And this is the second disappointment I've had. It's not a really bad disappointment, but I wouldn't recommend building this circuit unless you really build a lot of circuits and you want to see this thing lock. And what would really be cool, if it had a light on it, or an LED that lit when it was in lock condition. It doesn't, okay? It basically, if you're in between a lock, it's going to drift into the lock, okay? Your oscillator is going to drift, and then it's going to lock, okay? And that's why when you're going up and down the dial, you're not going to get the exact frequency you want because it drifts, it locks, what did I say, every 70 hertz? Yeah, every 70 hertz. So, I think that's it. Yeah, all right, that's it.